Dr. K. Welcome to this series of videos on internetworking, or networking for the internet. In this module, we're going to talk about networking as it applies to the internet and internet software. We'll look at packet switching, which is the fundamental way that internet communications take place. And we'll contrast it with the telephone networks that use circuit switching. We'll talk about TCP and UDP, the two major internet communication protocols. We'll look at the OSI reference model for network communication, and we'll talk about sockets, ports, and models for distributed computing. A key distinction when it comes to networks is the distinction between circuit-switched networks and packet-switched networks. Circuit switch networks are exemplified by the original telephone system. When you made a phone call, that call would establish a dedicated path to the person you were calling. The path was a two-way path, so there was a path of connected wires going from you to the other person, and then there was a path of different wires coming back to you, though it was usually just two wires inside the same casing. That path going out and the path coming back completed a circuit, so this was known as circuit switching. The internet works on a very different principle called packet switching. As soon as you have some data you want to send to someone over the network, that data is broken down into very small chunks of information called packets. Packets are about 1.5 kilobytes in size. And to give you some idea of that size, it's equal to about 1 page of plain text. Now that's not 1 page of a Word document because that contains a lot of hidden codes and other overhead, but 1 page of a simple text document in a plain text editor. So if you have any kind of significant data you want to send over the network, that data is going to be broken down into multiple packets of information. Each of those data packets is going to include something called a header, and the header is going to include bookkeeping information, like the address of where this packet is supposed to go, or the position this packet is in relative to the other packets in the document, or media, or the data that you want to send. This is important because some of the packets might arrive out of sequence, and they have to be reordered at their destination. And the reason that packets can arrive out of sequence is because the route that each packet takes is not predetermined, as it is in a circuit switch network. The route is determined as the packet is moving from router to router. Each router makes a best guess of where next to send an individual packet so that it will reach its destination in the shortest amount of time. Since the network is constantly changing, sometimes routers go down, sometimes routers get congested, the best guess at 1 microsecond might not be the same as the best guess at the next microsecond. We'll look in detail at a packet switching example shortly. First, let's take a look at a circuit switching example. You pick up the phone and you want to make a phone call. Now, in the really old days, you didn't even have to dial the phone. You would just pick it up and talk to the switchboard operator. Like this charming young lady here, whose switchboard was connected to your phone. And that connection was a two-way connection, as we said, a circuit. If the person you wanted to talk to was in another area, the switchboard operator would then have to contact another switchboard operator that got you closer to the person you wanted to talk to. This might have to happen a couple of times before your call eventually went through, but once it did, the resulting path that was created, the wires and the patch panel connectors that made up the circuit, was fixed. It was dedicated to your conversation. And when you spoke, all the information, all the electrons that represented your voice traveled in sequence down the same fixed path to the person you called. And when that person spoke, all of their information traveled down the return path back to you. Now, modern mobile networks have made that scenario a little bit more complicated, but the idea of a circuit is still there. And the idea that your voice data travels in sequence along a specific path is still there also. One thing that has changed is that circuits can be updated as you're moving geographically with your mobile phone during a phone call, as you get closer to a cell phone tower that is different from the one you originated the call through. Then something called a handoff has to take place, and the circuit is magically updated so that it goes through the closest tower. But it's still a circuit, and your voice data is still pipelining in the correct order through that circuit to the caller on the other phone. Now, because of the existence and reach of both circuit-switched and packet-switched networks, there are certainly ways that both types of networks can work together to transfer all kinds of data, whether it be voice, documents, or services, from one point on this global network to another. But the distinction between breaking up data and keeping it intact is still a critical one to understand. Okay, we've taken a look at circuit switch networks. Now let's look at packet switching. Let's suppose I want to send a document from my laptop to another computer on the internet. Suppose it's a text document that's 3 pages long. Therefore, it can be broken up into 3 packets. So the first thing that's done when you want to send information over the internet is to break up that information into packets. And that's mandated by the Internet Protocol, or IP for short. The first place those packets go is to your local router. And your local router doesn't have a very difficult decision to make. It has to decide whether that data is destined for something inside your local network, like a printer or another computer that's connected to the same router, or if the data is destined for something outside your local network. Since we said we're going to be sending data over the internet, it means that the data is destined to go outside the network, which means that your router is going to send the information to a router owned by your Internet Service Provider, or ISP. So let's send it there now. Now, the router at your ISP is connected to several different routers, and for each packet it receives, it has to make a determination of which router to send that packet to next, so that the packet reaches its destination in the most efficient way possible. In this scenario, let's assume that sending packets to the router across from it will usually get the packets to this particular address the fastest. Let's assume that when the first 2 packets are evaluated and routed, they're going to be sent to that router across from it. But now let's assume that in that split second between the evaluation of the second and third packet, the ISP's router learns that traffic at what is normally the best route to the final address has become congested, so that the new optimal route involves a detour to the router above. The first 2 packets have already been sent to the router across from the ISP's router, and the third packet is sent on the detour to the router above. And that's going to look something like this. Okay, so now the packets are not all at the same router. Let's assume that for the router handling the first 2, the first one of those packets is sent off rather quickly. But remember, that router is experiencing congestion, so the next packet is caught in traffic. Meanwhile, the the last packet is sent on its way without any problems. So the first and last packets are now at the router of the destination machine's ISP, and the second packet is still back at the router below it. Now, the first and third packets have made it to the local router of the destination machine, and the second packet is not far behind. The first and last packet make it to the machine, and the middle packet is almost there. And finally, all three packets have made it to the destination machine. However, they did not arrive in the order they were sent. Is there some way for the destination machine to reorder those original packets, like this? Well, that might depend on the higher level protocol that's being used to send the packets. The Internet Protocol, or IP, is the protocol that requires data to be broken up into packets, but there are protocols on top of, or over IP, that determine what to do in the case of lost, duplicated, or out-of-order packets, all of which can occur in Internet packet switching. Now, in the specific case of our text document, we'll almost certainly choose a protocol that does reassemble the packets in the correct order, which means that the document will arrive intact. However, in the case of, say, a live video stream, that late packet might be able to be safely ignored without significantly affecting the quality of the video. And if that's the case, a different higher level protocol might be used, different from the one used to send our document. So let's look at some of the potential problems that can arise with packet switching. First, the packets can arrive out of order, as we've seen. Second, some packets may be dropped or lost during transmission. This doesn't occur often, but when it does, it's usually due to traffic congestion. In fact, when any of these three things happen, it's usually due to congestion. And finally, a packet may be duplicated. This might happen, for example, if a router was sending a packet into a congested area. The router might decide that there's a good chance the packet may be lost, and it may duplicate the packet and send it along another route, just to increase the chances that the data in the packet will get to its destination in a timely manner. It will assume that the processing done at the destination is sophisticated enough to ignore any duplicate packets.